logic stuff. So we have got, there are more than these, but these are the ones that we worry about at GCSE. And, or, and not. Right, these just manipulate bit values, ones and nots. Okay, so and or compare, because there's two inputs. So if we look at the symbols first, and is the one that looks like a D. You shouldn't be making mistakes as to which symbol is which. So that looks like a D. You have two inputs, and we compare them, and we get an output. So we often call these inputs A and B. We don't always label the output, but you can label it with any letter you want. Okay, so let's use Q. Right. For all these logic gates, we can create a truth table that says how these values are compared and what output we produce. So you can write A and B, but there is another way of writing it that you have to get used to in case they use it in the exam. They can write that as A and then the logic symbol for and, which is sort of an A that hasn't got the line across. If you can remember just that one, you can work the other one out. We'll come back to that when we do all. Right, so we have to put down all the combinations of inputs that we can have. Because we've got two values, we can have not and not. And with and, if we have inputs of not and not, when we compare them, the output will be 0. We can have not and 1, and when we compare those with and, we output a 0. We can have 1 and 0, and when we compare those, the output is 0. When we get 1 and 1, the output is 1. Okay, so we're comparing these values. That's all we're doing. So in and's case, you only get an output of 1 if both inputs are 1. So it's actually the easy one to remember. Right, with or is the horrible symbol, which is like a D shape that someone's punched or crashed into or something. Very difficult to draw without it looking awful. So try and do it from the front and like go back in a sort of curve, and then try and make sure you do the same curve, and then try to just do the dint. So the or is dinted, okay, if that's even a word. Right, two inputs again, and one output. So I'm just going to carry the truth table along so I don't have to rewrite everything. So we can say A or B. But we can use the logic symbol for or. And the logic symbol for or is a V. It's the opposite of the and. So I always, because I can never remember this, so, but I do, because what I do is I concentrate on the and looks like an A. Just like the symbol for and looks like a D. And then the other one must be the other one then. That's how I remember it. So that is our or. When we compare values with or, as long as we've got an input of 1, we'll have an output of 1. So the first one where we got not and not, we go now nothing. But in all the other cases, you can see there's at least a 1. So we go, okay, we'll have a 1 for each one of those then. The only one of these that's different is not. Not doesn't compare any values. It's just got a single input. It's got the nicest symbol. I really like the not symbol, if you can like a symbol. Because it's got like a nose. It looks like a mouse. It looks like having a sniff. To me, anyway. Right, so it has one input and one output. And all it does, not, it just inverts. It's sometimes called inverter when you look at it on logic circuits. Because if you get a 1, you get a 0 as an output. If you input a 0, you get a 1. So it's like a flipper. So for a truth table for that, it's ridiculously simple to do. So you go, alright, we can input a 0 or a 1, and then we can say not, and that is just the opposite. Everyone's happy with that. That's the super simple one, isn't it? But there is a logic symbol for this. It's quite a weird logic symbol. It looks like that. It looks like the A's got a gun. It would make a really cool game if you made an ASCII game and you could have like a character that was an A going around with the not symbol. Shooting full stops at people. Or B's and C's and whatever. Okay, so you have to do that because the exam board may give you something like in logic format and say draw the circuit. Which I think on the question paper we did have that. Right, anyone got any questions about that so far? So the only other thing you've got to be able to do is to be able to look at a circuit diagram and write down what the logic is, or take some logic and write it as a circuit diagram. So you might get something like this. So you might have not A or B. And they'll say, right, okay, draw the logic circuit for that. So the way that you tackle this, you look at the symbols you've got. We've got A and B, so we've got two inputs. So the letters will represent inputs. So we go, okay, we've got an A and we've got a B. When you look at not has to be done first, unless you've got brackets, and I'll do a different version in a minute. Right, so I would say not A, so I go, okay then. I don't actually know exactly how this is going to turn out, but I can see there is a not A. So I'm going to say A goes into a not. That's me not A bit. Then I've got B. And what I'm saying here is this is OR with B. So the output from this not, right, what you've got to try and avoid when you're doing logic gates is doing this. Okay? A looks stupid, and B you're going to really mess it up. So try and keep them all the same size and change the lines. So I'm going to try and keep these at a reasonable size. And that is the logic circuit that represents that, not A ORed with B. But I could have written it like this. I could have said not A or B. Looks very similar, but what do brackets mean in maths? Yeah, do that first. So what I'm saying here is do OR first. So I'm going to do A and B. And I'm going to say, yeah, okay, let's OR them together. And then the output, I've got to do what's in it? Not A. That's all you've got to do when you're doing these diagrams. It's just a matter of saying, oh, just treat it like it was maths. There is a maths notation to boolean algebra, which is what this is. Okay, but I don't want to confuse you with that. That actually makes it a little bit simpler. If you want to look that up, look it up. Okay? Right, anyone got any questions about that? If, at A-level, we do this in a bit more detail and we look at some specific circuits and things. Okay, but we can explore that next year when we're recapping these things. We'll do a little bit of the A-level stuff. Okay, just to like give you a little bit of context. No? No question on that. Okay.